All right, so in this question, they ask us to find the area of this large triangle. Now, we know when we're talking about area, the formula for area is base times height divided by 2. So if I look at this diagram, a few different measurements that I need in order for this to happen is this whole length here, okay, and the height. Now you can see that obviously I don't have the height, so I'm going to have to find that. I also only have part of the base. So I have the 507, but I need to then also find x. So you can see in this diagram that there are numerous triangles. So the first thing I would do is I would separate the two triangles and see what I do know. So if I look at, obviously I also have, and I should have pointed that out when I was with my magic pen, obviously I have this right angle triangle. I also have a large right angle triangle. The only problem is with that one, I know just by looking at it that I don't have enough information to work with that. But then I have this triangle right here. Okay, so I'm going to use that triangle and the small right angle triangle to solve what I need. So obviously in this small right angle triangle, I can see, and I'm just going to bring both triangles out. So this is 35, this is x, and this is h. And I want to find both the x and the h, but I don't have enough information. So then I go to that other triangle, and sorry, pretend those are straight. So I have 21 degrees, and I have this bottom length. Now, when I compare what those two triangles have in common, they have one side length in common. And the side length that they have in common is this here. So if I could find this side length, I could then transfer it over to this triangle, and then I could solve for both x and h. So I'm not going to solve the whole question here. So I want to look at this triangle I have. So I can see I have 507 and I have one angle. Well, I do have more than one angle because there's 35, and I know that this is a straight line across here, so I know that that total measurement's 180. So to find that angle, I'm going to go 180 minus 35, and when we do that, we end up with 145 degrees. So that triangle now has 145 degrees, and I know 21, so I actually can calculate the top one now as well. This one here, and I'm just scribbling all over the place so you can understand. It's not my formal solution. I know that's going to be 180 minus the 145 and minus the 20. So you can see it's going to be a fairly small angle. So that's 165. So we're looking at 15 degrees. Sorry, got 165 from 180. Sorry, my brain's not thinking today. So 15 degrees. Okay, so that's 15 degrees. So now that triangle, I know all three angles and I know one side. So that means I can use the sine law because I know this angle and the side directly across from it. So I can use that piece of information to find then using the sine law the green side length, which then I can transfer over to the right angle triangle and use SOHCAHTOA. So still have problems, just let me know.